In this video, we'll be looking at Boyle's law. Boyle's law. So, what is Boyle's law? Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. The law states that the pressure of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. So, mathematically, the law states that P is inversely proportional to volume. So that's P is inversely proportional to 1 all over V. That's what this law states. It states that the pressure P of a fixed mass of gas is inversely proportional to the volume, provided the temperature remains constant. So provided the temperature remains constant, the pressure of a fixed mass of gas will be inversely proportional to the volume. Inversely proportional to the volume. What that means is that as the pressure, if the pressure increases, the opposite is going to happen to the volume. So if the pressure increases, the volume will decrease. This is what Boyle's law is all about. And if the volume of the gas increases, if it increases, the pressure will decrease. So in other words, the pressure of a fixed mass of gas is inversely proportional to its volume, provided the temperature remains constant. So provided the temperature of the gas remains constant, of that fixed mass of gas remains constant, the pressure, when the pressure increases, the volume is going to decrease. And when the volume increases, the pressure will decrease. So Boyle's law states that P is inversely proportional to V. That's P inversely proportional to 1 over V. So in order for us to remove this sign of proportionality, we'll have to bring in a constant. So that will result to P is equal to K all over V. So this constant that we have brought in has removed the sign of proportionality. So our K will be equal to P times V. K will be equal to PV. So this K, what we did here, this is like P all over 1. So what we did here is that we cross multiplied. K times 1 will give you K, which is here, is equal to P times this V, which will be equal to PV. So this K that we've gotten here is our Boyle's constant. It's known as Boyle's constant. Boyle's constant. So if we are comparing two gases, for instance, we have, let's say we are comparing two gases, two fixed mass of gases. This is P1 and this is V1. So we can have the equation as P1 V1 is equal to P2 V2. That is, if the pressure is at a particular level and the volume is at a particular level, what will be the pressure if the volume is increased? So this is now the equation that we would use when we are comparing gases, the same gas, the same fixed mass of gas, but when the volume or the pressure is increased, this is the formula we use. And we're going to look at examples to illustrate this. So the next thing that we should know after this is the graphical representation of Boyle's law. The graphical representation of Boyle's law. So I have this first graph here. This is a graphical representation of Boyle's law. Like I said, the Boyle's law states that P, which is the pressure of a fixed mass of gas, is inversely proportional to volume. So that means that as the pressure increases, when the pressure increases, the volume will what? Will decrease. So let's say here is 0, let's say millimeter cube. Here is 5 millimeter cube for the volume, and here is 10 millimeter cube for the volume. You can see as you go this way, the volume will be increasing. Then let's say here is 0 millimeter of mercury for the pressure. Here is 5 millimeter of mercury for the pressure, millimeter of mercury, and here is 10 millimeter of mercury. So an explanation of this graph goes like this. As the pressure increases, you can see that the volume is not decreasing while moving towards the side. The volume is decreasing, and so the pressure is not increasing. So as the pressure increase, let's say the pressure is slanted towards the increase, the volume of the gas will be decreasing. You get? And also as the pressure decreases, the volume of the gas will be increasing. It will be tilting towards the side of increase. So this is a representation of Boyle's law. You must know this graph. As the pressure increases, the volume decreases. Another graph that can illustrate this is this graph. That illustrates Boyle's law is this graph. So this is the pressure of the gas and this is the volume. So see it this way. Let's say I enclose this graph now. If I close this graph like this, let's just do something like this. As the pressure, this is a very big amount of pressure. Eh? As the pressure is big, the volume will be small. So big pressure, small volume. So as the pressure is getting smaller, the volume is now increasing. Look at it here, V, volume. So as the pressure gets very small, the volume of the gas will now increase more. So this is a graph that also illustrates Boyle's law. As the pressure increases, the volume will decrease. As the pressure increases, the volume will decrease. As the pressure decreases, the volume will not increase. So this is a graphical representation of Boyle's law. So having known this, let's look at the first example that we have here. And the example is what pressure will be required to compress 350 centimeter cube of hydrogen at 700 millimeters of mercury to 300 centimeter cube, temperature remaining constant. So let's have our solution here. If you look at this question properly, we're dealing with volume and we're dealing with pressure. So this should tell you that this is an application of Boyle's law. And Boyle's law formula states that P1 V1 is equal to P2 V2. So you must remember this formula. This is Boyle's law formula. So again, the question is, what pressure will be required to compress 350 centimeter cube of hydrogen at 700 millimeters of mercury to 300 centimeter cube? So what pressure will be required to compress this hydrogen gas that is having 350 centimeter cube of volume and 700 millimeters of mercury to 300 centimeter cube volume? If you look at this question properly, P1 is equal to 700 millimeters of mercury. Our V1 is equal to 350 centimeter cube. Our P2 is what we're looking for. It is unknown. Then our V2 is equal to 300 centimeter cube. So the question is, what pressure will be required to compress this hydrogen gas that is having a pressure of 700 millimeters of mercury and a volume of 350 centimeter cube to 300 centimeter cube? What pressure will be required to compress this gas with these parameters to this 300 centimeter cube? So what we do here is to apply Boyle's law, and this is Boyle's law formula. P1 V1 is equal to P2 V2. So our P1 in this formula is 700 millimeters of mercury times our V1 is 350 centimeter cube, then is equal to our P2 is unknown, so I will represent that as P2. Then our V2 is 300 centimeter cube. So 700 times 350 will give us what? 700 times 350 will be equal to 245,000. So that will be equal to 245,000 is equal to P2 times 300 will give me 300 P2. So to get my P2, I will divide both sides of the equation by 300, by the coefficient of P2, which is 300. So my P2 will be equal to 245,000 divided by 300. So 0 will cancel 0, 0 will cancel 0. So what I have there remaining is 2,450 divided by 3. So 2,450 divided by 3 will be equal to 816, which is approximately 817. So our P2 will be equal to 817 millimeters of mercury. So if we look at this equation very well, this is an application of Boyle's law. As the pressure increases, the volume will decrease. So for the first one, so our P2 now is 817 millimeters of mercury. So let's look at this. This is P1, the volume, this is P1, the pressure is 700 millimeters of mercury and the volume is 350 centimeter cube. So as the pressure increases, the volume has decreased. As the pressure increased, it increased from 700 to 817. The volume will decrease. And as the volume decreases, the pressure will increase. So this is an application of Boyle's law. In the next video, we'll look at another example, which is this example here.